Hello everybody. Today we will see how to write ionic equations to show the electron transfer in a redox reaction. A reaction that involves movement of electron from a substance to another substance. So we need to show the movement of electron so that we can really understand how a redox is actually taking place in a reaction. And that is why we are talking about writing half equation. We can use half equation to show the electron transfer in a reaction. And when we say half equation, what are we talking about? Let's use this reaction as an example. So this one will be a guide for us. Reaction between magnesium and oxygen to give magnesium oxide. Magnesium atom react with oxygen gas to give magnesium oxide. So we balance the equation. So this, I will call this one a full equation. This is a full equation. So this equation can be divided into two. It can be split into two. So by splitting this equation into two, we're talking about half equation. Of course, we have two reactants. Let's call this one reactant 1, reactant 1, and this is reactant 2. And in the product, we can also split the product into two. Let's assume that we want to split this product into two. This one will go for product. We will say product 1. Can I call it product 1? Or this one represent reactant 1. Let's call it reactant 1. Reactant 1. And we call this one reactant 2. So it means we can split this. If you look at it this way, we take the side of reactant 1, say Mg. Let me rewrite the equation first. O2 to give Mg. So I want to split this MgO this way. Mg 2 plus O2 minus. So we can easily pick the reactant ones and its rep. We pick them out, and we pick the reactant 2 and its rep out as well. So if I pick reactant 1, so it's going to be Mg. So I leave out the reactant 2, I put the arrow, then I put the rep of reactant 2 here in the product, Mg 2 plus. Yeah, that is a half equation. Half equation. So it means we've split the equation, the whole equation, into two to follow the patterns of reactant 1 and that of its rep, and that of reactant 2 and its rep as well. So let's take the other side for reactant 2. This is reactant 2, O2, then its rep is O2 minus. So this is another half of the equation. So when we say writing half equation, we've started writing half equation now. You can see how easy it is to write a half equation. So the next thing is to look at this equation, whether it is balanced or not. Remember, I did not take the balanced value here. The value that I used to balance the equation, I left them out because we are going to meet them, we are going to use them at the end of the day here, and we put them by ourselves without using what is here. So I leave out these two. I wrote Mg, and I leave out these two here, and I wrote only this Mg 2 plus and O2 minus. So the next step, if I call this one step 1, if I call this one step 1, the next step is to see um, is to uh, balance the equation. The two half equation, we look at them whether they are balanced or not. If they are not balanced, then we will balance them. Otherwise, then we leave them. Okay, so let's take the side of magnesium. Of course, we've seen our half equations now, and we are happy. So let's take the side of magnesium, Mg to Mg2 plus. So this is the next step. I call this one step 2. So for magnesium to become Mg2 plus, for Mg atom, this is magnesium atom, to become magnesium ion, something more has happened. So what happened? Magnesium atom to become magnesium ion, it means magnesium has lost 2 electrons. It means it has lost 2 electrons. Remember, magnesium is in group 2 and the electronic configuration is at 282. It is element number 12 in the periodic table. So it is going to lose these 2 electrons in order to become octet. That is, anytime it's want to bond with, to form whatever magnesium forms bond with another element or another atom, it will lose electron to that 2 electrons to that atom. So the sign of 2 electron being lost is what we have here. So this one is telling us that magnesium has actually lost 2 electrons. So we've seen that it has lost 2 electrons, but how can we represent that 2 electron loss? So it is very simple. We just put minus 2 electrons here. So we can read this out. Magnesium atom lost 2 electrons to become magnesium ion. So this is a half equation and this one is balanced already. So we can see balance now. So this is now balanced. So of course we've seen how the movement of electron, it has been seen now. So we can see that magnesium lost 2 electrons and it becomes magnesium ion. So we go to the side of oxygen. Because the reaction is between magnesium and oxygen and magnesium lost 2 electrons, automatically oxygen will gain the 2 electrons lost by magnesium. So if you put this, if you remember, that is what we have for oxygen, and we have O2 minus here. So it means that is oxygen molecule and that is oxygen ion. So there's a point that I want you to understand here. That is O2. Look at this 2 down here. It's telling us that this is an oxygen molecule, but there is no 2 down here. So this is just O with the charge on it. So a charged particle, of course, it is an ion. So this is oxygen ion. This is never possible. You cannot have a charge and have 2 down here as well. At this level, that is not possible. So what we are trying to say by having this, what we're trying to say is that this is oxygen ion, and at the same time it is oxygen molecule. So this is not possible. It is either you have this only to represent oxygen ion, or you have O2 down here to represent oxygen molecule. So we have 1 molecule of oxygen here. Remember, 2 atoms come together to give us a molecule of oxygen. So 1 molecule of oxygen here and 1 ion of oxygen here. The first thing we have to know is that this O2 means oxygen atom and another oxygen atom. So if we have 2 oxygen atoms this way, it means we must have 2 oxygen ions here as well. So we make this one 2 here. So this one means two oxygen atom with the same thing as one molecule of oxygen. It becomes a two oxygen ion here. This is very simple. It is like this: O to O2 minus, another O to another O2 minus. Oxygen atom, when they come together, they give us oxygen molecule, and this is oxygen ion, this is oxygen ion. When they come together, they are still oxygen ion. So it means we have two oxygen ions. So if you get that, then let's go down to showing the electron transfer. Now, I said that is not possible, remember? It is not possible. Okay. So, oxygen molecule become oxygen ion. How? It becomes oxygen ion because if you remember, look at the electron configuration of oxygen. It is oxygen is 2, 6. For oxygen to be stable, just like group 8 element, it will need to accept 2 electrons. So this sign here, that is this charge here, is showing that oxygen has accepted 2 electrons. That is one oxygen ion has accepted 2 electrons, and we have 2 oxygen ions here. It means each one of them has accepted 2 electrons. From where, of course, we can see the electron loss from magnesium here. So how do we show the transfer of electron here? So accepted, we use plus to represent that, because transfer, loss of 2 electrons is minus, gaining of 2 electrons means that gain of electron will be plus here. So oxygen molecule, it means there are 2 oxygen atoms here. Each one of them accepted 2 electrons. So it means it's going to be 4 electrons. 4 electrons. Why 4 electrons? Again, O will gain 2 electrons. Another O will gain 2 electrons. So if you put them together, this will be O2 and this will be 4 electrons. So that is how we got these 4 electrons here. So each one of them will now become one oxygen ion, and the other one oxygen ion. And at the end of the day, we have 2 oxygen ions. Remember, you don't change this. It cannot be 2 oxygen ion. It is not possible, please. So this is just like a man, and this is just like another man again. So when they come together, they become 2 men. So that is what this one means. 2 men. Okay. So in those cases, that is in the case of magnesium to magnesium ion and oxygen to oxygen ion, we have seen the sign of electron loss here, and we've seen the sign of electron gain here. So that is a balanced half equation. That is another balanced half equation. So at the end of the day, we can put them together to get an ionic equation. We get ionic equation from combining 2 half equations. So this is the half equation, this is another half equation. Let's combine them together. So I will call this one, I will say combining the half equations. Combining the half equation to form an ionic equation. To form an ionic equation. So let's see. The half equation again is Mg lost 2 electrons, and it becomes Mg2 plus. Why oxygen molecule gain 4 electrons to become 2 oxygen ions. So we want to combine the two half equations. So it's just very simple. Before we can combine the two half equations, we must check the electrons. Since we said the electron lost is electron lost by magnesium is the electrons gained by oxygen. So it means if magnesium loses 2 electrons, oxygen must gain 2 electrons. So we can see magnesium is losing 2 electrons here, but oxygen is gaining 4 electrons. So it means this equation has to be corrected. How do we correct this equation? We just balance this equation. If you remember your simultaneous equation, you just multiply everything here by 2. So you want this value of electron to be same as the value of electrons here. So it's going to be 2 times everything here. So if you do that, you're going to have something like this. So let me write it tiny. Let me bring this one down first. So we'll have something like this here. 2 mg minus 4 electrons to become 2 mg 2 plus. Nothing will happen to the charge here. We just make this one to be 2. That's what we just need. So at the end of the day, we can cancel out the electron. This one will cancel out this. So at the end of the day, we are going to have, if you combine them together, we will have 2 mg, that is 2 atoms of magnesium. So react, we just put, like, you put plus here and then you put plus here. Very simple. So it's going to be plus O2 to give us a 2 mg2 plus 2 O2 minus. So we have combined the two half equations. So the two half equations has been combined at the end of the day. So we have seen how to write half equation and how to combine the two half equation to give us an ionic equation. Again, we started with this equation, reaction between magnesium atom and oxygen molecule to give magnesium oxide. We said this one represent reactant 1, this one represent reactant 2, and this one is a representative of reactant 1 here in the product, and this representative of reactant 2 in the product. So if we split these two, we have this for the side of magnesium and this for the side of oxygen. So this is magnesium half of the equation, that is the oxygen half of the equation, and we have written half equation already. But the only problem is that the half equation might not be balanced. So this one will tell us how to balance the equation. So how do we do that? We show the movement of electrons. Magnesium is in group 2, so it will lose 2 electrons. So by losing 2 electrons, we have to show it here. So it means magnesium lost 2 electrons to become magnesium ion. This one has been balanced. We go to the side of oxygen. That is oxygen molecule. There are 2 atoms of oxygen here. So each one of them will gain 2 electrons. So that is why we have 4 electrons here. And they will give us 2 ions. 1 ion from the first atom, 1 ion from the second atom. So we have 2 ions here. This one will not change. It will still be 2 minus because it's showing that each atom has gained 2 electrons. So if we want to combine the two equations, combining the two half equation will give us an ionic equation. And these are the two half equations. This is the first half of the equation, this is the second half of the equation. But if oxygen gained 4 electrons, magnesium must have lost 2 electrons. So we balance the electrons lost and gained by multiplying all the sides by 2 in order to make this to be 4, and it go with this 4 here. So we got this minus 4 electrons here. So this one we cancel out this, and at the end of the day we add the reactant and we combine the products. So by doing that, we've constructed a half equation. This is a balanced half equation. If we put this together again, it will give us 2mgo. So to give us the full equation the other time that we started with 2mg plus O2 to give us a 2mgo. So that's it. Thank you very, very much. So we'll see next time, inshallah. Assalamu alaikum.